anymore. No, China's paying 55% and a potential 155% come November 1st unless we make a deal. And I'm meeting with President Xi. We have a very
中国主义的老路，背弃和平发展承诺，破坏战后国际秩序，中国人民不会答应，国际社会不会允许，最终只能以失败告终。
Artificial intelligence often looks like software. ChatGPT, image generators, recommendation systems, but none of it exists without something much more physical: silicon. Every AI model, no matter how advanced, ultimately runs on chips, and today those chips are at the center of a geopolitical struggle. This is not just a technology story, it's a power story, because whoever controls AI hardware controls the speed, scale, and direction of artificial intelligence itself. This is the chip war. AI is not software, it is infrastructure. When people talk about AI, they usually talk about models, GPT, Claude, Gemini. But AI models don't float in the cloud. They run on physical machines, inside data centers, powered by electricity, built on semiconductors. Training a large AI model requires tens of thousands of GPUs, massive energy consumption, specialized networking hardware, advanced cooling systems. Without high-performance chips, modern AI simply cannot exist. So the real question becomes, who builds those chips? Who designs them? Who manufactures them? And who controls access to them? Why GPUs became the center of AI. Originally, GPUs were built for gaming. Graphics processing units were designed to render images quickly. But researchers discovered something important. GPUs are extremely good at parallel processing, and AI training requires massive parallel computation. So companies like NVIDIA moved from gaming hardware into AI acceleration. Today, AI training clusters rely heavily on NVIDIA A100, NVIDIA H100, advanced AI accelerators. These are not consumer products, they are strategic assets. A single high-end AI GPU can cost tens of thousands of dollars. Large AI companies buy them by the tens of thousands. This is not software scaling, this is hardware concentration. The supply chain is global, but fragile. Modern semiconductors are not made in one country. The supply chain spans design in the United States, manufacturing in Taiwan, equipment from the Netherlands, materials from Japan, assembly across Asia. This system evolved over decades for efficiency, not resilience, and that matters, because the most advanced chips in the world are primarily manufactured by one company, TSMC, Taiwan Semiconductor Manufacturing Company. And Taiwan sits at the center of geopolitical tension between China and the United States. That means AI infrastructure depends on geopolitical stability. The role of NVIDIA has become the dominant AI hardware supplier. Why? Because it invested early in CUDA software ecosystem. It optimized hardware specifically for AI workloads. It built long-term relationships with researchers. This created something powerful, a hardware plus software lock-in system. If you build your AI systems on NVIDIA architecture, switching becomes expensive. So dominance compounds. Today, NVIDIA is not just a chip company, it is a gatekeeper of AI capability. Enter the United States government. In recent years, the US government has taken an increasingly active role in semiconductor policy. Why? Because advanced chips are no longer just economic tools, they are strategic military assets. AI is used for surveillance, defense modeling, cybersecurity, autonomous systems. This changes everything. The US introduced export controls limiting the sale of advanced AI chips to China, specifically targeting high-end NVIDIA GPUs, advanced AI accelerators. This wasn't about business competition, it was about slowing AI development in rival states. Semiconductors became foreign policy. The CHIPS Act. In 2022, the US passed the CHIPS and Science Act. It allocated tens of billions of dollars to domestic semiconductor manufacturing research supply chain resilience. Why subsidize something that used to be private industry? Because reliance on foreign manufacturing, especially Taiwan, is considered a national security risk. The logic is clear. If AI is strategic and chips power AI, then chip manufacturing becomes strategic infrastructure. China's response. China has not remained passive. For years, China invested heavily in semiconductor independence, but advanced chip manufacturing requires extreme ultraviolet lithography machines, specialized manufacturing equipment, intellectual property access. The most advanced lithography machines are made by ASML in the Netherlands. and export controls have limited China's access to them. This has slowed China's ability to manufacture the most advanced nodes domestically. So China faces a constraint: strong AI ambitions, limited hardware access. That tension defines the current phase of the chip war. Why this is different from previous tech races? The semiconductor race is different from previous technology competitions. Why? Because it's capital intensive at an extreme level. Building a cutting-edge fabrication plant can cost tens of billions of dollars. Only a few companies in the world can afford it. This creates concentration, and concentration creates leverage. Unlike software, which can scale quickly, chip manufacturing is slow, expensive, and highly technical. You cannot build a competitor overnight. Cloud providers enter the game. Companies like Amazon, AWS, Microsoft, Azure, Google Cloud are not just renting computing power. They are building custom AI chips. Why? Because reliance on NVIDIA is expensive and hardware margins are high. So we now see Google TP-US, Amazon Trainium, Microsoft AI infrastructure investments. This shifts the battlefield. Now the war is not only between nations, it is also between tech giants. The energy dimension. AI chips consume enormous amounts of energy. Training frontier models requires massive power draw, dedicated data centers, grid-level electricity planning. Some data centers consume as much electricity as small cities. So AI hardware dominance is not just about silicon, it is also about energy infrastructure. Countries with cheap, stable energy gain advantage. What happens if Taiwan is disrupted? This is the unspoken question. If Taiwan's semiconductor production were disrupted, global AI development would slow dramatically. Car production would slow. Consumer electronics would stall. Military systems would face shortages. The world economy is deeply dependent on a small geographic region. That fragility is the core risk. Who really controls AI? Not just model builders, not just software engineers. Control lies across layers. Chip designers, manufacturers, equipment suppliers, cloud providers, energy grids. Government's AI is not controlled by a single company. It is controlled by a network, and that network is shaped by geopolitics. The future. We are likely to see more export restrictions, regional chip ecosystems, government subsidies, strategic stockpiling. Hardware diversification AI capability may increasingly align with geopolitical alliances. This is no longer just market competition, it is strategic infrastructure planning. Artificial intelligence feels digital, but its power is physical. Silicon wafers, factories, energy grids, export licenses, government policy. The chip war is not about headlines. It is about supply chains, and supply chains shape power. Because whoever controls AI hardware does not just build faster models, they shape the future of intelligence itself.
And make no mistake, this is China versus the world. They have put these unacceptable export controls on the entire world.